Now if we check the network value for all of them, it would give us 1,000, and we check the balance of all of them, it would give us 1,000 as well. So there's no value loss in the transactions. Now let's say we're gonna have C to B 60 at 15. In this case, let's say it would be at 15%. But since this would be a transaction of backward value transfer, because C has less network value than B, so the network value will be flowing to C. The maximum rate at which C could make that transaction would be B's, which in this case it would be 15%. That's B's public rate. So let's make the transaction. In this case, since it's a backwards value transfer, it over registers the transaction by the double of the additional rate, which in this case is in this case it would be 15%. Yeah, it would be of 9, so it would be double of that. So the value of the transaction is, of the link, is 78 at 15%. The deducted value here would be 131, and B would receive the 60, so it will be 295, and to the auxiliary account would go 9. In this case, we check again. It receives 1 transaction to the auxiliary account, but the number of links plus 1 is 2. So it doesn't meet the distribution condition yet, so it doesn't distribute. Now let's check the network value for C. In this case, it would be 131 plus 78, so it would yield 209. And in this case, it would give us 326, because it's 295 plus 9 plus 100 minus 78. This would give us 326. Again, if we sum the network value of all, would give us 1,000, and the balance of all plus the auxiliaries would give us 1,000 as well.